Hi. Okay, so for 3A, we're going to start with percentages. And I apologize if there's noise in the background. I am recording this at home, um, and my kids are at home in quarantine, so they're kind of making some noise out there. Um, okay, so we're going to do an introduction to percentages. So there's two basic ways of using percentages. We can talk about it as a fraction or part of a whole, or we could talk about it as a comparison. So as a fraction, it could be something like a total of 13,000 newspaper employees. Um, or of a total, right, there's a typo there. So out of a total of 13,000 newspaper employees, 2.6% of the newspaper workforce, oh, sorry. So 13,000 newspaper employees, which are 2.6% of the newspaper workforce, lost their jobs. Comparison, so Citigroup stock fell 15% last week to 44.25, where the advanced battery lasts 125% longer than the standard one, but costs 200% more. Now, the word percent literally means per 100. Um, and per in math means divided. Cent, you think of like a penny is a cent. So it means 100. So in math, we use the symbol, the percent symbol as shorthand for percent. So if you read 50%, what it literally means is you have 50. This means divided by 100. So 50% would be 50 divided by 100, which in decimal form would be zero point 0.5. So if you're going to convert um, fraction or percents to fraction, all you have to do is replace the percent symbol with division by 100 and then simplify. So 25% would mean 25 divided by 100. And simplifying this, whether by hand or by calculator, would give you 1/4. So 20% is a quarter. Now, if you're going to percentage to a decimal, you're going to replace the percent sign by dividing by 100. Um, so you would do 25 divided by 100, and you would get the decimal 0.25. No, because all of our place values are just powers of 10, and 100 is a power of 10, all that means is you're moving the decimal point 2 places to the left. So if it started here, 1, 2 over to get 0.25. So the reverse way, if you're going from decimal to a percentage, you're then going to multiply by 100. So you can think of it as decimal is a smaller number, percentage is a larger number. So decimal, you have to multiply by 100 to get to that percentage. If you go from percentage to decimal, you're going smaller, so you need to divide by 100. So for 0.43, we're going to move the decimal place over twice, or we multiply by 100 to get 43. And because we multiply by that 100, we then have to put that percent sign back in. Okay, so now if we're going to convert from a common fraction to a percentage. So we start with a fraction, and we want to change to a percentage. So we can convert the fraction to decimal by just dividing. So you do 1 divided by 5, and so we get 0.2. And then you do what we just did to convert from a decimal to a percentage. So we're going to take that 0.2 and multiply by 100, or move the decimal place to the right to get 20%. Okay, let's look at an example. So express the first number as a percentage of the second number. So in 2015, there were 61 million Americans under age 15 out of 321 million Americans. So we're going to write this as a percentage. We want to have this as a percentage of this. Now, note both of them say millions. So I'm just going to look at the numbers because those match. Okay, so we're doing 61 Americans out of 321. So you do 61 divided by 321, and we would get 0.19003. Now in MyMathLab, it'll tell you in particular what to round to. Right now, I'm just going to put out several. And so we have a decimal, but now we want a percent. So it says express it as a percentage. So we're going to move this over twice, or we're going to multiply by 100. and to get 19.003%. Now let's talk about a little bit more about fractions being a part of a whole. So the keyword we're looking for in these problems is the keyword of. That is really going to tell you that we're looking at a part of a whole. Now, there's also another word that's going to be in there is. There's is and of, and that tells you where to put your information. So the number that goes with the is, that is your part. Number that goes with of, that is your whole. So it's always going to be is divided by of, part divided by whole, and then you change that fraction to a percent. So in example 2, we have 112 freshmen is 26% of the school's entire student body. So how many students attend the school? Okay, so it says 112 freshmen is. So that means this is goes with the 112 freshmen. Then we have the word of the school's entire student body. So the entire student body is your of. And then this percentage is going to be the result of the division. So we have 112 part over the whole. Now we don't know what the entire student body is. That's what I was asking for. How many students attend the school? So I'm just going to put a placeholder there, a variable. And when I do that division, I'm going to get 26%. So from here, if we wanted to solve for x, we want to figure out what the school's entire student body is. We can do a cross multiplication, which we can do because we have this equal sign. And we're going to say that this is a fraction 26% over 1. So I have 112 over x. Now my calculator, I don't really like the percent, so I'm going to go ahead and change that to 0.26 over 1. Right, because percent means divided by, so we do 26 divided by 100 to get 0.26. Cross multiplication says we do 26 times x equals 112 times 1. And to solve for x, you divide both sides by 26. And you get x equals 430.769. Of course, you can't have a point of a person, so we're going to go ahead and round that up to say we have 431 students in the school. Now to check that, you can then find what 26% of the 431 to double check that it is indeed 112. So we do 26% of, or we can even do this 112 divided by 431, and you should get 0.26. Now it will be rounded, of course, since we have rounded these numbers. Okay, let's look at another one. So we purchased a bicycle with a retail price of $760. The local sales tax rate is 7.6%. What is the final cost or after tax? Okay, so here we have to kind of think about it a little bit because we have this percent here. And you have this retail pre-tax price of $760, and then you have the final cost after tax. So here we don't specifically have this is and of relationship. We do have this word of here, but this is saying it's the retail price of $760. It's not like a percentage of something. Whereas in this one here, we have a percent of the schools. Okay, and here we just have a retail price of $760. So we kind of have to think about this and put it in our sentence so we can have an is and an of. Well, we know that sales tax in this case is 7.6% of the retail price. Correct? So they take the sales tax by taking a percentage of whatever the pre-tax price was, the retail price. Why I put a question mark, I don't really know there. Okay. Okay, so now we have an is and we have an of. So sales tax is my is and of is my retail. Well, I don't know my sales tax. amount, but I do have my retail price of 760. So I know my sales is 7.6% of 760. Okay, so of in math means multiplication. Um, so you can think of it that way, where your sales tax, which you don't know, is 7.6% as a decimal, is 0.076 of 760. Or you can say, if we're still using the same formula that we were using here, we have sales tax is the is, so that's your part, what we don't know, divided by your of, which is 760. And when you do that division, you should get to 7.6%. Now, again, if we put this over 1 and we um, multiply across here, then you get x times 1 equals 7.6 as a decimal, 0.076 times 760. And multiply that together, and you get 5776. Now, we're not done yet because they're asking for the final cost and not just the sales tax amount. So to get the final cost, we're going to take your pre-amount, your 760, we're going to add on what you have to pay for taxes. So 760 plus 5776 gives you a final cost of $817.76. And last example here. So your dinner bill is $42.50 and you leave $50. What percent tip did you leave? Okay, so our bill is $42.50. We leave $50. So the tip is going to be whatever is on top of the bill. So the amount of the tip is going to be what I paid minus what the bill is. So that is $7.50. So our tip is $7.50. So we want to know, okay, what percent tip did I leave for this waitress or waiter? So we say the tip is what percent of the bill. So in general, right? So your tip is going to be some percentage of your bill. So because the is with the tip, the of is with the bill, tip goes on top, bill goes on bottom, and that will give you your percent. Now we have the amount of the tip is $7.50. The amount of the bill was $42.50. So we divide that and we get 0.17647. Change that to a percent is 17.647%. And then, of course, you would round it to wherever my math lab tells you to round to. So in this case, it's a decent tip. $7.50 is a 17.647% tip. Okay, so that was part of a whole. So we can also use percent to compare things. So we can talk about comparison over time, like how something changes from like one year to another, or we can talk about comparison between just two like things. So let's first talk about time. So the key word here for these problems, you're gonna have some sort of word that indicates that it changed. So whether it's increase or decrease or the actual word change. Um, So suppose you're looking at the population of a town. Let's say this population rose from 10,000 people a decade ago to 15,000 today. So we can talk about that change in two ways. We talk about an absolute change. This is just the regular number, the actual number that it changed by. So to find that, you're just going to take your new value and subtract off your old value. It's just the basic difference between where it ended and where it began. Now, note we do the new minus the old um, to get the change. If it's negative, that would mean it decreases. Okay, so for our example of 10,000 and 15,000, if we would take this 15,000, which is our new, and subtract off what we started with, we know it's new because it is a later date, right? We would get 5,000 people. So it increased because it's positive. We can say it increased 5,000 people, and that is the absolute change. Now, relative change, that's going to be relative to what it started with. So it gives you a little bit better idea sometimes of how big of a difference that change was. So relative change is going to be a fraction. It's going to be a fraction. It's a percentage comparing the new value to the old value. So overall, you have new minus old divided by your old value. You can also think of it as the absolute change divided by your old value. I always just remember the new minus old divided by old. Whichever one that you are more comfortable with, you can do that. Okay, so in our population example, we had the increase of 5,000 people. So the new minus your old, which is where we got that 5,000, we would divide that by our starting amount, which was 10,000. And so if we did this division, note when you put this in the calculator, you have to make sure you put parentheses around this subtraction. Otherwise, you'll get 15,000 minus the 10,000 divided by each other, which means your answer would be 14,999, which is not correct. So we have 15,000 minus 10,000 divided by 10,000, and you would end up getting 0.5 or 50%. So we say the relative change of this population, 50% or 0.5. Notice again that because it is positive, it means we are increasing and not decreasing. So let's look at some examples. So between the 2010 US Census and 2015, the estimated population of El Paso, Texas increased from approximately 649,000 to 681,000. During the same period, the population of Chandler, Arizona increased from approximately 236,000 to 260,000. Which city had the greater absolute change in population? Which city had the greater relative change in population? So here we'll compare the numbers and why percentages can be a little bit more useful than just the change amount. So let's look at Texas first. So in Texas, it went from 649,000 to 681,000. So 681 is our new. If we want the absolute change, we take our new value, 681,000, subtract off 649,000. And we would get 32,000 positive. So the absolute change in Texas is they increased 32,000 people. Okay, so the relative change is we're going to take our absolute change, this new minus the old, we're going to divide that by the old. So what it started with was 649,000. So we divide that and we end up getting a 0.0493, which as a percent is 4.93%. And we take the decimal and you multiply it by 100 to get your percent value. Okay, so Texas increased by 32,000 people, which is 4.93%. Okay, now let's look at Arizona. So the absolute change in Arizona went from 236 to 260. So 260 is my new. So 260,000, and we're going to subtract off my old, which is 236,000. Over here, we get 24,000. So Arizona, comparing the two absolute, Arizona did not increase by as many people as Texas. So for Texas, this was the larger amount. So just looking at the absolute values, it looks like Texas had a greater change in population. But let's look at the relative to see what that tells us. So we have our new minus the old, which is our absolute change. And we're going to divide that by our old, So it's what we started with is 236. And we do this, we get 0.1017, which is 10.17%. So notice that is a 10% change, 10% increase in Arizona. So notice that difference here between this 10% and Texas is 4.93%. So even though Texas increased by more people, you would have seen the difference more in Arizona because it would increase by 10% um, rather than only 4.93%. Okay, example 6. Find the absolute change and the percentage change. The number of commercial U.S. oldies radio stations was 729 in 2006 and 351 in 2016. Okay, so 2006 is the older number, the older year, so that's going to be your old. 2016 is your new. So the absolute change is going to be your new minus the old. So 351 in 2016 and 729 in 2006. And that gets us a negative 378. Remember, this negative means that it decreased by 378 stations. Okay, note also that because I said the word decrease, I don't have to put that negative. It's either one or the other. If they ask for just the change, like in this case, it says find the absolute change, you would put in this negative 378 into MyMathLab. But if it said find the amount it decreased or the absolute decrease, it has the word decrease in here or somewhere that means something like it, like lessen or falls or anything that means it goes down, then you don't have to put the negative here. Okay, so the absolute change was negative 378. Now the percentage change, so sometimes it'll say percentage, sometimes it'll say relative. Sorry about that. You can just, it's all going to be the same thing. So relative is going to be your new minus your old, which is what we just found here. So it's negative 378. And you're going to divide that by your old amount, which is 729. And we get a negative 0.5185, which is a negative 51.85%. So it decreased by 51.85%. So it decreased by a little bit more than half. Note, if we had divided this by the new, if we had done negative 378 divided by the new one, which is 351, this would have been a number greater than 1. So that would mean that it completely went away and it would not give us the right answer. So make sure you are dividing by the right one. Okay, so that was comparison of across time. So let's look at comparison of two like things. So this is when you're talking about, you're comparing, let's say like my height to yours. Most likely I'm shorter than you, right? So we're comparing two things. We're going to have this word then, and that is your big keyword here. So the other one was of, this one is then. If you see a then, that tells you you're going to be comparing. And in everything that, or not everything, but the thing that follows then. So like if you say, I am shorter than you are going to be classified as the old, and I would be the new. So your book and MyMathLab, that's going to be, they're going to use different words for it. They're going to be using comparison value and reference value. To make things simpler in my head, I just keep using old and new. But in MyMathLab, your new value is going to be your compared value, and your old is going to be your reference value. So in case you see those words, that's what they mean. But I'm going to keep using new and old. So let's say we're comparing the price of a Mercedes to a Lexus. Let's say the Mercedes costs $50,000 and the Lexus costs $40,000. So just like before, we can look at the actual dollar difference or the actual number difference, or we can look at a percent difference. So so I'm, we can say like, the Lexus is, um, a certain amount less, or we can say that it's a certain percentage less, just like we could with the um, comparison over time. Okay, so absolute difference is still going to be new minus old. Now, um, if they don't actually have the then, like if they just said compare the Mercedes to a Lexus, then you kind of have to pick which one. But my math lab will usually tell you which one to use as the reference value, and that reference value is going to be the old if they don't have that word then. Most of the time, though, it will have the word then. So let's say if we're going to say the new is the Mercedes and the old is the Lexus. Okay. So to get the absolute difference, we're going to take the price of the new, which is 50,000, and subtract off the price of the Lexus, which is 40,000. Get an absolute difference of $10,000. So we say the Mercedes is $10,000 more than the Lexus. Which is what we have here. Mercedes costs 10,000 more than the Lexus. Now, if we switch it around, let's say the new is the Lexus and the old is the Mercedes, then we have 40,000. I'm going to subtract off 50,000 because in this case 50 is the old. Now you have a negative 10,000, which means that the Lexus is $10,000 less than. That negative means less than. So Lexus costs $10,000 less than the Mercedes. Okay, so relative difference works similar. You're still going to have new minus old in parentheses divided by old. So again, if you're going to have Mercedes as the new and Lexus as the old, you can take the absolute difference, which in this case was a positive 10,000, divided by the old, which is the Lexus value, which is 40,000. And you get 0.25 or 25%. So we can say that the Mercedes cost, because Mercedes is our new, so Mercedes costs 25% more than the Lexus. Notice we have then and Lexus. So Mercedes is 25% more than the Lexus. Now, if we were to switch this around, let's say the new is the Lexus and the old is the Mercedes. Now we're using this negative 10,000 and dividing by our old, which is the Mercedes, and that's 50,000. That gets us a 0.2 or negative 0.2 or negative 20%. This negative says we're going less than. So the Lexus is 20% less than, because it's negative, less than the Mercedes. Okay, note here that in both of these comparisons, this relative change, or the relative difference, this percentage amount, is really just another way of having the part of a whole. Where the absolute change is the part and the reference value is the whole. Um, so let's look at some examples. So the life expectancy at birth of all Americans in 2014, which was 78.8 years, is what percent greater than life expectancy in 1900? Okay, so we have this greater than. So what is after the then is your old. So, I mean, we can also look at the time here, right? So, because 1900 was our older value, this is going to be the old, and 2014 is the new. But don't, just because it has those numbers, remember this then is going to tell you exactly which one your old is. So, we want to find the percent. So, we want the relative change. So we're going to do our new minus old divided by our old. So we have 78.8 minus our old, which is 47.3. We're going to divide that by 47.3. And then we get a 0.66596, which as a percent is 66.596. And then, of course, round it at the end to whatever you need to. So say, for example, I wanted you to round it to the nearest percent. If you look at this whole number, and this would be 67%. Okay, example 8. In 2015, the median age of first marriage of U.S. women, 27.1 years, was what percent less than the median age of first marriage of U.S. men, which was 29.2 years. So we have less than, which means that my men were the old and women is new. Okay, so to get the percent, I'm going to do my new, which is 27.1, minus my old, which is 29.2. You divide that by the old, which is 29.2. And I get a negative 0.0719, which as a percent is negative 7.19%. I know we have this negative, but because we have this word less than, our answer is going to be positive 7.19%. In example 7, we have the word greater. So we just leave it as a positive. But because this says less, we want to change this negative to a positive. Okay, now let's talk about converting between a part and a whole in comparison. I mentioned that they are pretty much the same, so we can convert fairly easily. So let's consider a population that increases from 200 to 600. So the keyword increases tells us that we're going to be using a comparison percentage. So if we use the formula that we just used, the new minus the old divided by the old, we can find the population increased by 200%. All right, so we do our new minus our old and divide by old. And that gives us 2, which is 200%. So the population increased by 200%, which means that the later population is 200% more than the previous population. Okay, so if we were to calculate the current population size, like from the old one, you would take 200% of the previous population. So you take 200 times 200%, and then you'd add it back on to that population of 200. So in this case, right, so you do 200% of 200, right, because of in math means multiplication, and you would end up getting 400, and then you would add that 400 back to the original population to get 600. Yeah? Okay, so just looking at percentages. So you want 200% of the current population, and then add it back in. So that's your new is the current plus increase. The current population is 100% of the current population, right? Because 100% just means 1. Multiplied by 1 doesn't do anything. So because the current then is 100% of the population, the increase is 200% of the population, we can then say that the latter population is 300% of the previous population size. Note, we can also check this by using our part of a whole formula to verify that 600, right? Because we say we have this is and of. So we put the latter population as our is, that's a 600, divided by the previous population, which is 200. That does give us a 300%. So 600 divided by 200 is 3. Change that to a percentage would give you 300%. Now, Let's say instead of increasing, it's going to decrease. Let's say it decreased from 800 to 200. Well, that means the population decreased by 75%, which we can find by taking the new minus the old divided by the old. And this would give you a 0.75 or 75%. Actually gives you a negative 75%, but because it's decreasing, we can just use the positive 75. So it decreased by 75%, which means the latter population is 75% less than the previous population size. So using we have here, so the new is the current plus increase. Instead, it's going to be the current minus the decrease. So you have the current, which is 100%, minus the amount that we're taking out, that we're decreasing, and then we have 25%. So the latter population is 25% of the previous population size. Again, is the latter, of is the previous. So the latter population is 200. The previous population is 800. This would give you 0.25, which is 25%. So this is the long explanation of how we get it. But in general, the rule is that if you're increasing, if it's more than, that means you're going to add on 100 to your percent. If it's less than, you're going to subtract it from 100. No, we can also take it one step further because we know that of in math means multiplication. We can change the percent to a decimal and then change of to times, which we'll see here in example 9. So we have the wholesale price of a toaster is 30% less than the retail price. Therefore, the wholesale price is how many times the retail price? Okay, so we have then, which means my retail price is going to be my old value, and my wholesale price is going to be my new value. And I have 30% less than. So 30% less than, so because we're decreasing, we're going to subtract from 100. So we have 100 minus 30 is 70. So that means it is 70% of the retail price. So if we have the retail price, it would be 70% times that retail price, right? But they don't want a percent here. They don't want 70% times. What they want is the decimal. So we change 70% to a decimal. So divide that by 100 and you get 0.7 times the retail. So this 0.7 would go there. So wholesale price is 0.7 times the retail price. Okay, example 10. We have the original retail price of a TV is 20% more than its on-sale price. So here we have more than, which means we're going to be increasing in price, which means we're going to be adding the 100. So instead of saying 20% more, then we're going to add on the 100. So we have 20 plus 100 to give us 120. So we have 120% of the retail price, or the sale price, more than its on sale price. But again, it wants the times. So we're going to translate this. So 120% is going to be 1.2. We take 120 divided by 100. Of in math means multiplication, which another word for it is times. So the retail price is going to be 1.2 times the on-sale price. Okay, example 11. A store is having a 40% off sale. The sale price for an item with a regular cost of $80 is... Okay, so here we don't have a then, but because we have this increase, we can write it in a more or less than statement to figure out what it is. So we know that the sale price is going to be 40% less than the retail price, right? You figure out the sale price, or the 40% comes from your original price. So 40% less than. So we don't know. We have the regular cost. We have the retail cost. So that is here. and we don't know the sale price. Okay, so the sale price is 40% less than the $80. So less than because it is going down. We need to subtract it from 100. So 100 minus 40 is going to be 60. So the sale price is going to be 60% of $80. So again, if you're going to take this part of a whole, you have the x over the 80 equals 60%. Or if you just translate from English to math, you have the sale price, which is what we don't know, is in math means equals 60% as a decimal is 0.6. Of in math is multiplication, and then 80. So your sale price is 0.6 times 80, which is $48. Example 12, the final cost for your new shoes is $107.69. Local sales tax rate is 6.2%. What is the retail or pre-tax price? Now I know it's really tempting to just find 6.2% of the 107, but remember that would be a tax on the new cost and not what it originally was, and the tax is supposed to be on what it originally is. So to figure that out, um, we can say that our final cost is going to be 6.2% more than the retail cost. All right? So tax is 6.2%, so it's going to increase it by 6.2%. So we know what the final cost is. The final cost is 107.69. It is 6.2% more than retail, which we don't know. Okay, so more than, we're increasing, so that means 107.69 is going to be 106.2% of your retail. So translating it into math, we have 107.69 is this equals 106.2% is going to be 1.062. Of means multiplication, and your retail cost, which we don't know. So I'm actually going to put just x for my retail cost. So it's 1.062 times x. Solve for x. We divide both sides by 1.062. So my x is going to equal 101.40. Of course, I'm rounding this to the nearest cent because we are speaking in dollars and cents. Okay, example 13. Your total cost for dinner in a restaurant after the tip was $76.40. Assuming you left a 20% tip, what was the bill for food and taxes? Okay, so all in all, you left the restaurant paying $76.40. You paid a 20% tip. So what was the original bill before you paid tip? So we know our final bill is going to be 20% with the tip more than the bill. Our final was $76.40. More than we're increasing, so it's going to be 120% of the bill. So just like we did here in example 12, we have 76.40 equals 1.2 because 120% as a decimal is 1.2. Of means multiply, we don't know the bill, so we'll have a placeholder or a variable. Divide both sides by 1.2, and you get that your food bill was $63.67. Okay, last example. Simon's monthly take-home pay after taxes is 2,200. If he pays 20% of his gross pay, his gross meaning before taxes, in tax, what is his gross pay? So your take-home pay is going to be 20% less than your gross. Less than, of course, means you're going to decrease. So this time we're going to be subtracting. So 100 minus 21 is going to be 79. So your take-home pay is 2,200. 21% less than means it's going to be 79% of your gross pay. So again, just like the last two, we have 2,200 is 79% is 0.79. Of means multiply, so 0.79 times your gross. Divide both sides by 0.79. So here the x is 2784.81. Note here that if you are having trouble figuring out or remembering this algebra part, what you can remember, good space to write this, is if you have the old value or your is, then you're going to multiply your two numbers. So that was for I'm sorry, if you have got that a little backwards in my mind. Okay, so this first one we multiplied, in example 11, we multiplied because we had the then. So that is your old value. So if you have the old value, which in this case is your of, so the of 80 less than 80. So if you have that value, then you're going to just multiply two numbers together, your percent and your number. However, if you have your new value, which is your is, then you're going to divide it. You're always going to divide your is divided by your percentage. Always putting that percentage as a decimal. So that's what we did. So this first one is what we did here, and this is what we did on these last examples. Okay, anyway, let me know if you have any questions.